Okay, guys, this is a review for the quiz tomorrow, section 7.3 through 7.5. The first thing that you have to remember for the first two problems is that there are three properties that you have to remember. The first property is when you have two angles from one triangle similar to the other two angles of another triangle. So then you can use the angle-angle similarity theorem. Another theorem that you can use when two triangles are given and you have to prove them similar is the side-angle-side. Side-angle-side similarity theorem. Here, the angle has to be in between the two sides that are proportional. So sides need to be proportional and the angle has to be in between the two sides. The third one, it's side, 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 and here the three sides are supposed to be proportional. So in problem number one, if I look at number one, I have one angle given on the base, and this is an isosceles triangle. And then I have an angle on the vertex. This is an angle Q that is given. So what you can do, you can say that if angle A is 70, angle C would also be the same because you have congruency marks on the side. So that's an isosceles triangle, so the base angles would be the same. That would be 70 degrees. So to find the measurement of angle B, all you gotta do is add both angles and then subtract that sum from 180. So the measurement of angle B, it's 40 degrees. So as you can see, you have an included angle that is in between the two sides. And the two sides that I'm talking about are AB and BC. See, these are included. These are sides that have an included angle. So angle A is congruent to angle Q. Okay? So I can mark those two congruent. I can say, well, angle B, it's congruent to angle Q. And just to say a number, since I don't have numbers on the sides, if I say AB, for example, it's 6, so BC would be 6. And I'm just giving out numbers, okay? It just has to be that those two sides have to be the same. Now, if you look at the triangle PQR, it's also an isosceles triangle. So if you think about a number, doesn't really matter which number you think of. If you think about a number, for example, if PQ, it's 1, and RQ, it's 1. And if you compare the sides from one triangle to the other triangle, you're going to have that is going to be AB is to PQ, and that's going to be AB, it's to PQ, and just, trying some numbers, that would be 6 over 1. And if you compare the other pair of sides, which is BC, the same ratio, BC over RQ, the same ratio as the previous one, and the answer is yes, it's 6 over 1. So then the sides are proportional, and you have an included angle. So therefore, those two triangles are similar by the side angle side. So that's what you need to mention on those lines. You first need to say what is congruent and what is proportional. So you have to say, since angle B, it's congruent to angle Q, and the sides are proportional, comma, then, and this is the statement, okay? Then triangle ABC, it's similar to triangle PQR by what? Because you have to explain why they're congruent. So this is going to be by the side angle side similarity theorem, and that's the reason. Now in problem number 2, if you look at number 2, what we have is we have two overlapping triangles. So what is recommended that you do is you need to draw the two triangles that you have there. Okay? So triangle ABE, that's a small triangle. You need to compare and say that that is similar to triangle ACD. Okay? So if you think about it, angle A, it's overlapping over to angle A. So this angle is the same angle because it's just overlapped. So you can just mark those two congruent. By the reflexive property, let me just write it on the lines or on the left side. I'm going to say, okay, triangle, angle. Angle A, it's congruent to angle A by the reflexive property. That's one thing that you can mention. Another thing that you can mention is, well, if you see these lines are parallel. So if I have lines that are parallel and then I have a transversal passing through that, what you can say is that this angle is congruent to this angle. And I'm going to just do a little sketch, a small sketch of what is happening. Okay? So see here, when you have that line, that is this line. And this parallel line is this parallel line, which means that this angle would be congruent to this angle. You remember those are corresponding angles. So in that case, we're talking about angle B is congruent to angle C. So here I can say angle B, it's congruent to angle C by corresponding angles. So since I'm already mentioning two pairs of angles, then what I can say as a conclusion, because it's explained, okay, I gotta explain why those triangles are similar. So since I already said those two angles, those two pairs of angles are congruent, then I can say triangle ABE, it's similar to triangle ACD. And then the reason will by angle similarity theorem. So once you prove that those are congruent, then you can go ahead and find the measurements of the sides. So I need to find BE and I need to find CD. Okay, so let me go ahead and put the numbers. They're giving me for AE, that is 3. Now notice that AC, it's both of the numbers together. So when I need to add them up, 3 plus 4.5, it's 7.5. And then I have X, and I have X plus 6. Okay, now let me make this a little bigger so we can really see that and see what's going on. Okay, now what I can do, I can compare AB is to AC as BE is to CD, and that's what I'm going to write. I'm going to write 3 is to 7.5 as X is to X plus 6, and then you can just cross multiply. So 3, it goes in the front. When you have a binomial, two terms, you got to make sure you put that in parentheses. 7.5x. Okay, and then you have to distribute 3 times x and 3 times 6. So that would be 3x plus 18 equals 7.5x. 7.5x. And then when you try to combine x's, you have to move the smallest. All the time it's better to move the smallest x. So that is 4.5x when you subtract. And when you divide by 4.5 both sides, that would be 4. And since I go back and I look at the x, which is this one, BE, well, that would be 4. And then CD, instead of x, that's 4. So I can just plug it in. I can say, okay, so x here, it's 4, and this is 4 plus 6, side CD, so that would be 10. So let me come back and now write my answers. Okay, I'm going to write my answers, and I'm going to put here, because they needed for me to give BE. So BE, it's equals to 4, and CD, it's equals to 10. And those are the two values that we're asking me for. Okay, now problem number 3. Let me get rid of that work. Let me just cut that off. Okay. Okay, so let me just get rid of this information. Okay. Okay, so let's move on. Problem number 3. Let me get rid of that information right there. Okay, so number 3, all we have to do is just find the length of the segments. It's just, draw the triangle separately. I'm going to draw F, H, J, which has a 20 and an 11. And then the other triangle, it's F, E, G, and that is, we need to add 30 plus 20, which is 50. And then I'm going to let just FG be X. I'm going to find that piece first, okay? So by finding X, which is the whole piece, later on I can come back and I can just subtract the 11, and that would give me the JG, okay? This piece that I'm looking for. So let me set it up. The proportion would be 20 is to 11 as 50 is to X. When you cross multiply, that is 20x equals to 550. Then you divide by 20. So x here would be 20, let me see, 40. Let me do this math. That is 2, 40, 15, carry a 0, so that is 7. 140, 10, so it's 0.5. So x is 27.5. And then I come back and I plug it in. See, this is 27 and this piece is 11. So the whole piece, 27, I can say, well, it's 27.5 minus the 11, and so JGE is the difference of those two, which is 16.5, and that would be the answer. Okay, next problem, number 4. In problem number 4, it's an angle bisector. So what you can say is that an angle bisectors, the side x plus 5 can be set it up as the base, 12.5, equals as the side of the triangle, x minus 5, is to the base of the triangle, 7.5. then you just cross multiply. Be careful with the binomials, okay? When you get the binomials, what you need to do is make sure you put the outside number, 7.5, outside the parentheses, and then is 12.5. Let me erase that plus, is supposed to be equals. So equals, then is 12.5 parentheses x minus 5 is inside the parentheses. And then you distribute 7.5x, you distribute, plus that's 25 carried 2, 35 and 2 is 37. You distribute, that's 12.5x, and then you distribute negative, this is 25 carried 2, and then is 10, 12, so it's 62.5. Then you have to combine the smallest x, so you subtract 7x from both sides, and that would be 5. So you're going to have 37.5 equals 5x minus 62.5. Then you add 62.5, 62.5, and that would gives you 100. When you divide by 5, x equals 20. So x is 20, but they want the measurement of angle of side SR, which is this one. So it's 20 plus 5, well, that would be 25. And then the second one, it's 20 minus 5, and that would give you the 50. Okay? Next, number 5. When you're checking to see if the sides are parallel, what we need to do is set up the proportion. They're saying the property says that if the lines are parallel, then the pieces should be proportional. So when you set up the proportion, you have to say it's AB over BC, or it could also be AB to AC, okay? I'm just putting AB to BC, which is 9 over 13.5. Now, is that the same thing as setting up the second ratio? AE is to ED, which is 12 is to 18. Then you put that into the calculator. Okay, let me use my calculator. So in my calculator, I put the 9 divided by 13.5. 9 divided by 13.5. And I have a decimal. That is 0.66667. That is 2/3. And when you divide 12 divided by 18, see, by 6 is 2, by 6 is 3. So it's the same thing. Since the sides are proportional, then your conclusion would be, since the sides are proportional, comma, then the lines BE would be parallel to CD. Okay, and that's it.